So this is the third question related to calculation of equivalent capacitance. So this is another circuit with a number of capacitors connected in the given way, and we have to find out the equivalent capacitance between these two points A and B. Okay. So again, as I told you, whenever you come across a circuit across which you have to find out the equivalent capacitance, be it equivalent capacitance, inductance or resistance, whatever, the first thing which you need to do is to find out the patterns of connections of the circuit elements. Okay, pattern of connection means whether a given number of elements are connected in series or parallel, and then you subsequently keep on reducing each circuit elements, group of elements, and simplify them into a simple circuit. So here we can see that these two microfarad capacitors, they are connected in parallel because there are two ends. Okay, the left end and left end, they are connected at one point, and the other two ends, they are connected at one common point. So we can simplify this circuit as this. Okay, this is simply the addition of these two capacitances, the equivalent capacitance, that will be 4 microfarad, 2 plus 2, 4 microfarad. This is 6 microfarad. Okay, then we have another 4 microfarad here. Then in between this we have a 2 microfarad, and then here this is A and B. Okay, now if we look at these two capacitors, 4 microfarad, which is the resultant capacitance of these two capacitors, and this 4 microfarad, if we can see these two capacitors, then they are connected in series. Okay, as they are connected in series, the equivalent capacitance of these two capacitors will be simply 4 into 4 by 4 plus 4, which is equal to 16 by 8, equal to 2 microfarad. The equivalent capacitance will be 2 microfarad. Okay, now we will again reduce it. We will just do it here. Okay, instead of again drawing it again, we will reduce it here. 2 microfarad. So it will be 2 microfarad. Okay, so we found out the equivalent capacitance of the two 4 microfarad capacitor which were connected in series, and we got it as 2 microfarad. Now these two 2 microfarad capacitors, okay, this capacitor and this capacitor, they are connected in parallel. So the equivalent capacitance of these two capacitors connected in parallel will be simply 2 plus 2 microfarad, that is 4 microfarad. Okay, so let us reduce it down again. Okay, so it will be 4 microfarad. Okay, 4 microfarad. Now across the points A and B, we have the 6 microfarad capacitor and this 4 microfarad capacitor. Now see, now just look at here. We have reduced this much portion of the circuit. Okay, this much portion of the circuit. Okay, this much portion of the circuit, we have reduced it and found out the equivalent capacitance to be 4 microfarad. We have kept on reducing, simplifying, and we got it until 4 microfarad. This highlighted blue highlighted portion. Okay, this much portion of the circuit has equivalent capacitance of 4 microfarad, which is connected in series with the 6 microfarad capacitor. So now the equivalent capacitance of the total capacitance across the points A and B will be 6 into 4, because they are connected in series, and the equivalent capacitance is given by this. 6 into 4 by 6 plus 4 equal to 24 by 10 equal to 2.4 microfarad. So the total capacitance, okay, this is equal to CAB, this 2.4 microfarad. Okay, the total capacitance across the points A and B. So just see again, the tip is the same. Whenever you come across a circuit, first of all we have to identify patterns of connection. Okay, patterns of connection. Here when we looked at this circuit, we just we found out that these two capacitors, they are in parallel. We simplified it into, we converted into one 4 microfarad capacitor. Then that 4 microfarad capacitance and this 4 microfarad capacitance, they were in series. So again we calculated the equivalent capacitance and we got the equivalent capacitance as 2 microfarad. Then that 2 microfarad and this 2 microfarad, they were in parallel. Then we calculated the equivalent capacitance and we got it as 4 microfarad, the addition 2 microfarad plus 2 microfarad. Then again this 6 microfarad and 4 microfarad, they were in series. So the equivalent capacitance across AB, finally we calculated it as 6 into 4 by 6 plus 4, which is equal to 2.4 microfarad. Okay, so this is the third question which we have solved related to equivalent capacitance of circuits. Now please do check out the other two questions also which I have posted related to equivalent capacitance so that you can understand more and more concepts. Okay, different patterns of connection of circuit elements and different ways of solving. Okay, so let us take some more questions related to equivalent capacitance.